Let me introduce myself. My name is SÉRGIO do NASCIMENto MAÉDA. I'm a student of master program in production engineering at Universidade Federal Fluminense, and I will present this article about the analysis of technical and economic feasibility of implemented electric propulsion in passenger transport vessels in Brazilian Navy. And if you don't mind, I've prepared some notes to help me in this presentation because I don't speak English very well. Sorry. Well, the access of students from the first naval districts to Ilha das Enxadas, located in Guanabara Bay in Rio de Janeiro, occurs through vessels that carry out a daily travel routine and generate a considerable consumption of diesel oil. So the purpose of this work is use the HAP method to analyze the technical and economic viability of implementing the electric propulsion using lithium-ion batteries in new vessels in order to replace the current ones, which use the conventional diesel system. In the context of economic development combined with the preservation of the environment, the adoption of electric propulsion in vessels has been gained great importance, establishing as one attractive option in the naval environment. However, the decision to adopt new technologies to replace existing ones must be made calculously, considering the possible impacts on the environment where it will be inserted. In this context, the operational research through the tools of multi-criteria decision support is very useful to help the decision maker to make the best choice. For the analysis, the technical and operation data of these vessels were considered. These data were obtained from technical manuals and interviews with the militaries responsible for their maintenance and management. For the cost of acquisition, we requested quotation to companies in sector. After data collection, the HAP method was used to identify which propulsive system offers the greatest advantage, being evaluated in light of four criteria: social and environmental aspect, total gross mass, acquisition cost, and operation cost. To contextualize these vessels, the CAW-07 Canopus 2 and 08 Sirius 2 were built in 1981 and have its structure composed by wood and fiberglass. Daily, they make the itinerary of from the first naval district to Ilha das Enxadas at a speed that varies between 6 to 7 knots, with an average crossing time of 20 minutes. This table presents the consumption data of CAW vessels during the period from January to May 2019. We can see that the average monthly consumption of diesel oil is around 4,500 liters. Basically, the system, the conventional diesel propulsion analyzed is composed by two propeller lines, each one with a MWM-229 turbo diesel with its reverser, and generating a total power of 194 kilowatts. To estimate the gross mass of this propulsion, we considered the mass generated by the volume of the storage tanks with the mass of the engines and reducers, resulting in a total mass of 1,931 kilograms. The electric propulsion proposed is composed basically by the battery bank, the converters, two synchronous, three-phase synchronous engines, a management system to monitor the engine and the battery bank, a battery charger for solution LAN, and a display for interface with the operator. To estimate the gross mass of the electrical system, we consider the mass of the engines and the battery bank. And to estimate the mass of the battery bank, first we check the volume of diesel oil spent on a trip. And then with its density, we calculated the mass used. So with its calorific power and the efficiency of the electric and diesel engines, we estimated the energy that should be stored in a battery banks that to make one trip. Finally, with the energy density of a lithium-ion battery and consider that each vessel should make at least 4 trips, we estimate the total mass of the battery bank. Therefore, we obtain the total mass of 2,160 kilograms. Well, to measure the cost of acquiring the systems, we requested a commercial proposal from companies in sector, where the lowest cost for diesel system was 270,000 reais, and for the electric propulsion system, the estimated cost was 1,135,000 reais.
Mr. Maeda, you have 3 minutes.
Thank you. To estimate the operation cost of diesel system, we just multiply the volume spent by the price of liter, and we did the same for the electrical propulsion, multiplying the price of 1 kilowatt hour by the total energy spent on a trip. The application of ISAHP method. For this application, the data collected were presented to the manager, who performed the judgment of the criteria and alternatives. We can verify that the criteria operational costs and social environment aspects were considered the most important in the decision maker evaluation. After the comparison of the criteria and the alternatives, we obtained the final result. It was observed that the decision maker showed a 4 times greater preference for the adoption of the electric propulsion system in relation to diesel. To finish, we can conclude that the acquisition cost of the electrical system is approximately 4 times higher than the diesel. However, its operation cost is approximately 4 times lower. The mass of the electrical propulsion system is 10% greater than conventional diesel, which does not represent a technical problem. It would even assist in the stability of the vessel. To the decision maker, the operation costs and social and environmental aspects were considered the main criteria. And the ISAHP method was presented as a robust tool for the analysis, considering the quantitative and qualitative criteria, providing a consolidated technical base for choosing the decision maker. Well, this is what I had to present. Thank you for your attention and apologize for my bad English. I hope be able to answer any questions. If not possible, I leave here my contacts to answer by email. Thank you.
Thank you, Mr. Maeda, for the presentation. Do you have any questions?